All right, welcome to the Vision series of labs for AI-102. The first of which is about analyzing images using Vision. So again, I'm going to go through both the C# and Python codes for the purposes, and we should have everything installed. So we have the Git repository already cloned, and then we already have created our multi-services account in Azure. If you don't know how to do that, then please refer to lab number 1, where we're going to go through that specific part. So for this lab, our code is here under 01 Analyze Images. I'm going to start off with the C# option or version. And the first thing I need to do here is I actually need to install the SDK for image analysis in .NET. So how does that work? Well, .NET add package, right? And then Azure dot, what was that? Azure dot AI dot vision dot image analysis. And in the instructions, we're asked to use a beta version. Here it's 1.0.0 beta. There are newer versions available. However, I haven't tested them, so I'm going to use the one that they give us in the instructions. All right, so that's done. Then we go to app settings again, and we copy over the app settings from our multi-services account. All right, so we have a key here. That's going to be under services key. And then we got the endpoint. It's got to be over here. Cool. So that's done, and that's saved. And then let's take a look at the code. So what is this code actually doing? Now this is incomplete, so we need to use the instructions to complete the code. This is missing the Vision SDK namespace, so we need to add that. So using Azure Vision image analysis. Oh, come on. Image analysis. This is supposed to be it. Okay. All right. Then let's go over downwards. So we see we have our code here. Make it a little bit more space as well. Our main method here is going to read in the configuration, and then what we want to do is authenticate. Okay, so we should have everything here. We have the service endpoint in this string, and we have the key in this string. So we should be able to create a client. And because we're using the namespace of Vision image analysis, the object we're going to create is an image analysis client. Okay, I'm just going to call it client, and we're going to assign to it just a new one, and as parameters we're going to give, not that one, I was hoping for a new line here, a new URI, which is the endpoint that we have previously paused. And then the second parameter needs to be the credentials, right? So I'm going to say new Azure key credential, and it's going to be the key itself, that one. All right, so this looks good. All right, then we're going to call the analyze image function. So let's go over there, or method, I think I should say here. So here is as image. So we're getting the client as a reference as well as a image file string. And then we're opening that file, okay? And then we want to get results. So the way this works is what we're going to get back is something called an image analysis result. Okay, that's the type. I'm just going to call it result. And so what we're going to call to get that is from the client that we previously, or that we're actually getting as a reference here. We're going to call the analyze method. And the analyze method takes different kinds of nice parameters, right? So one thing that we can do here is we can actually, first of all, give it the image data, right? It's going to be, we have a stream, so we can do binary data dot from stream, no, not from bytes, from stream, yeah. And then the stream that we created there earlier. Come on. And then we can give it a set of features that we're really interested in, right? So these are called visual features. So the way we do this is we refer to them, visual features dot, let's say caption, all right? And then in addition to that, we also want visual features dot dense captions. And then we also want visual features dot objects. And then we also want visual features dot tags. Okay. And what else is there? Visual features. People. Yeah, people. People is good. Okay. So we get all of that stuff back from the client. So that's the request part, kind of. And then we want to display results. Again, we have no code here, so we need to work on that. So let's first get the captions. So to be safe here, let's do if result dot caption. So note that all of the options or features here are typed. Dot text is not null, right? Then we can print it. Do it like this. So we do a console write line with caption, and then do like a couple of empties, and then hyphen, And then let's get the caption text. Can't see any of my highlights here. Caption text. Caption has an attribute called text. And then we might also be interested, oops, just one, in the confidence. So let's add that one. Confidence, and that's going to be a result caption. Confidence. And then we want to put that into 2 decimal format. Right. So that's there. And then we want to have a new line. Where are you? Okay. So 0, 0, 0. And then we want to have that one. And then we want to like this. Right? So we have some empty space, and then result caption text, and confidence, result caption confidence, new line, so on. Should work. Then we have dense captions. So it's right line. Dense captions. I guess these are always returned. That's why we're not checking null here. And then for each. Oh, well, maybe this for each just takes care of if it's empty, then there's nothing, right? Dense caption. Dense caption in result dot dense captions dot values, right? So we iterate over that. Then we get console right line. $. So $. And I need 1, 2 empties. Maybe 3. Caption. And let's put it like this now. From dense caption the text, right? And then we close this one. Yeah. And then we want the confidence, maybe a comma here. Confidence. And for that we need to have from dense caption the confidence. 0.00. That's like that. Okay, now we have the captions. So let's save. Not too many complaints. Let's see if this runs. So .NET terminal. .NET run, and then we need to give it a picture, and we think we have images here and street there. So images /street. Lots of errors. 80. It's this dodgy one, right? What was I supposed to put in? Text. Missed that. Yep. Better. Let's try again. Still got a problem. Row 95. Oh yeah. What's the problem here? I think we're missing like a end of command somewhere. Yeah, this one is missing the close. There we go. All right, seems to be working. So let's take a quick look at what this picture looks like. So this is the street at JPEG that we see over here. The caption is a man walking a dog on a leash on the street. Yeah, fairly good. There are more men walking on the street, a yellow car on the street. It's a taxi, yeah. A black dog walking on the street. A blurry image of a blue car. And a yellow taxi cab on the street. So fairly nice, right? All right. So next up, let's take a look at the tags. So going back to our program over here, we can add a bit of additional stuff that we're going to get back from our service. So let's say that if there are tags available, if the result tags, and here we have to go with the count of the values. If it's bigger than, where are we here? Yeah, 0. If there are more than 0 tags in here, then what we want to do is write them out, right? So we want to do n, and then tags, and then for each, and then we call it detect tag. Call it tag in result dot tags dot values, and for each, what we want to do is write a line. It's going to be some empty spaces, and then the tag name, right? And then confidence It's nice to see the confidence score. And that's in confidence. And this time, let's again make it a floating point with 2 decimals. And now just use the F2 macro for it. And that should be it. Right. So now we have all of the closing curly braces here. So that should work. Another kind of task in Vision would be object detection. So we could see if we have objects, and again, you know, if the count of those objects is greater than 0, then let's write objects will follow. And then we need to do some drawing here. So so let's first close the existing stream. We don't need that anymore. And just do it like this. And then let's create an image. And let's set it to, that's so weird. This, yeah. Drawing image from file. Right, and then our file. That one. Image, what was it? File. All right, so we got an image. Oh yeah, we gotta call it something. Let's call it image. And then let's create graphics. Image, right? And image. And then we need a pen. New pen. And let's make color cyan. Weight 3. We can actually see it. And then we also need a font. New font. Let's take something like Arial. The size could be 60, apparently. And then a brush. That could be maybe white. White smoke is good. All right. So now we got all of our drawing stuff. So now for each object that was detected, let's call it detect object in result dot objects dot values, right? So for each object that was detected, let's do the following. Let's first of all do a right line. want to intend this a bit. Right, and then add detected. Come on, detected object dot tag, the first one. There are multiple, so we need to choose the one at index 0. Here we go. 0th tag, and we want its name. Okay, and then we're happy with this, and then we want to add that end quote. Okay, and then we want to draw a bounding box around that. So we're going to pick up the bounding box first. Oh, somehow I'm in Chinese now. So we want to have the bounding box. Right. I'm going to create a rectangle around it. Rectangle. Right, I guess. Cause a new rectangle. And then we get all of our values from R. So R.x, R.y are the starting points. And then we get the R dot width and R dot height for the size of the rectangle. Seems correct. Should work. And then we draw that rectangle on top of the picture, right? So from graphics, we call draw rectangle, and first we need the pen, and then we need the rectangle, and then we also want to draw a string, and here we want to use the name of the tag, tags. We want the first one, and its name, right? Then we need a font and a brush, and then we need a point. So let's just put it at the top of the rectangle. Rx, Ry. I think we have to change these into floats. For this to work. All right, and then the image has been created. So next we want to save it somewhere. We're going to call this thing output file name, right? And let's just call it objects, JPEG. And then we save the image we created into that file. And then maybe write that again. Results saved in output file and then an end of line. All right, quite a bit of code here. All right, that should work. Next up, we could detect and locate some people as well, but let's run our program in a while. We haven't run it in a while, so let's do that now. So saving this, and then let's run it against the street picture. Well, we've got a bug here again. 105. What did I do wrong? What? I can't create a pen like that. Ah, yeah, it's too small, right? Can't see anything. The 3? Ah, I didn't save. All right, one more try. All right, here we go. So we got quite a bit of data here. So we have the captions that was the same as before. Now we also have some tags. These are kind of the highest confidence tags that were available. Then we have objects, a car, a taxi, a person, and a dog. And those should have been saved here in a new image. Let's just kind of take a look at that. And yeah, there's a car, there's a person, there's a dog, and there's a taxi. We could say that both of these are actually taxis, or both of them are cars. But, you know, maybe we're not too picky for this specific demo. So things seem to be working surprisingly nicely. Okay, so next up, let's work with the people detection part. So I think, yeah, we're here. And now we can again say, like, if the result has people, and again we're doing it like people.values.count is larger than 0, then what we're going to do is first say people, right? And then we need an image again, right? So drawing image. I'm going to call it an image. We're going to generate it from a file. And the file name was image file. Okay, then we get some graphics. That's from the image. Which was the image. Okay. Running in the pen. Let's use the same kind of pen as before. Font. Oh, not name of. new. I'm gonna use Arial and 16. And then we need the brush. I could have just copy pasted that from above, now that I think of it. Okay, and now then for each detected person, let's call him a person, in result dot person people dot values. All right, for each of those, what we're going to do is get a bounding box. This is coming from the person bounding box, correct? And then we create a rectangle based on the information therein. And we need the top left and top right corners, and then the width and the length, height. That one. And then we use graphics to draw the rectangle with the pen. Right. Then we could save that image again. This time let's call it persons.jpg. Image save. Output file. And then let's let the row user know that we did this. Results saved plus output file and for a new line. Okay. Let's see if this works. Let's again run it on the first option, which is the street JPEG. Oops. Right, so now I have also persons here. If we take a closer look. Now, make this bigger. So yeah, we can see that there is a person kind of here. And there are lots of small persons here. It's not very good. And I think it's very high confidence about those. We could also try to run this on our other pictures that we have here. So I'm just kind of .NET run images building. I don't know. Building. So here we get a totally different kind of set of captions. All right, so let's take a look at the original, yeah, or maybe the objects here. So yeah, it's the capital, and that's the object that's being found here, a building. And then with persons, I can see that I have a lot of small persons here around. I know if all of them are true. That's what it thinks. And then we had person.jpg as well. Let's try that one. Okay, so here under objects, we just have one object, which is person, and then under person. Actually two. But yeah. Gentleman's suit. Interesting. A man in a suit giving a thumbs up. But yeah, so this is how this works with the C# part. So next up, let's redo this in Python. So let me just get rid of this stuff here. And let's get over to the Python directory. All right, so let's do everything in Python. This is actually a new session that I started now. I was running low on time on the previous one. So we got a new one, but I think I did all of the prerequisites that are required for us. So we can kind of start from scratch from a Python point of view. And the one thing that we need to do is go into this directory and then install the image analysis package for Python. And now the problem is that the instructions are telling you to install the beta package, but that is not working anymore, kind of based on my quick investigation. So let's, instead of doing the specific version, let's just install the latest one, image analysis, right? So that's happening now. While that is installing, we can set up the .env environment here. So what we need to do is copy paste the key for our API. As well as the endpoint. And yeah, these have been changed since the previous part of this lab, because we didn't have time to do everything doing that one thing. So that's saved. Cool. So then let's go and take a look at our code. So this code snippet is missing the namespaces imports required. So what we want to do is we want to get from Azure AI Vision dot image analysis. We want to import specifically image analysis client. Very good. And then similarly, we have a data model here. Which is called visual features. We just use this for the request. And then we need the credentials as well. Azure core credentials import Azure key. Right. So that should take care of the imports that we require. In the main method, we're getting the configuration settings from .env. That seems right. We're setting a default image file here. And then we want to authenticate a client. So let's do that. So the way to do that is to define a image, or maybe I think it was called CV. Yeah, CV underscore client. Let's define that one as a new image, no, an image analysis client with the following configuration. Okay, so we have an endpoint. Let's use named argumentations or keyword arguments here. An endpoint that equals the AI endpoint that we got from the .env. And then we need a credential. So let that be a new Azure key credential. Oh no, I'm still in C# mode. And Azure key credential, right? With the key as parameter for that. Cool. Well, this should work. So this should create a client for us. And then we want to run the actual request. That's in the analyze image function here. So this would be here, right? So we'd say that the result comes from, we got the CV client here as a parameter. Yeah. And then on that, we want to call analyze. And then as parameters, what we want to add is some image data, which of course image data. And then we want to have some visual features. And that's going to be a list. Oops. So I'm going to have visual features, caption, similarly as previously, visual features, dense, captions, visual features. Oh, it's a bit slow. Dot tags, and we also the objects, and then finally we want to have people. All right, cool. So that's it. Let's just for sanity's sake add the comma here. So we could add any additional stuff as well. Then going down to the display analytics results. So this is missing everything. So let's first get the captions. So if in result there is a caption that is not none, then what I'm going to do is I want to print stuff. We're going to start off by printing new line and caption, right? And then we're going to print the actual caption. Right. Oops. There we go. And then close that one. And then add the confidence. As being another value, which is going to be a floating point with two significant figures, sorry, two decimals. All right. And then we should be done. So that string we're going to format with giving it as parameters result dot caption text and result dot caption dot confidence times 100. All right. So that's cool. So let's just kind of try this stuff out first, because like I said, the API changed. So we should be able to do Python image this.py. So yeah, it's getting us the caption back nicely. Very good. So we can continue. So our next thing is to get the dense captions. So if the result dense, I'm not getting any help here. Dense captions is not none. Then what we could do is print maybe dense captions. And then for each caption in result captions list, we want to print each one. So we're going to say like caption, oops. And then the caption. Like this. And then confidence. Hey, that didn't go right. So we're supposed to close this one. Yeah. And then confidence. And then we're going to have the confidence in here. And I'm going to format it as floating point with two. Decimals. And then we should be done. And then this string we want to format by giving it the caption text, it seems. Oops. As well as caption confidence. Times. Oh no. Again. All right. So that should work. Save again. Let's just quickly check. So we're doing okay. If result, dense caption in not paste is not none. This is my favorite typo. I make it all the time. All right, now we're getting the dense captions as well. Great. So next up, let's get the tags. Right, still here. If I guess now we have to do like this. No, we don't. We still do it the same way. If result tags is not none. Oh. Right? So if the tags are not none, then what we want to do is print tags. Right? And then for each tag in that tags list, we want to print one space and then a tag, the tag. That's so weird. It doesn't allow me to close this one. No, I want to have a single. A single one. Tag. Confidence. Again. The floating point with 2 decimals. Value. And then we close that one. And then we close the string. And then we say dot format. And then we give it as parameters the tag name. I think tag confidence. Again. Oops. And then we multiply that way. Okay. Let's check. Yeah, we got the tags as well. Cool. Okay, it seems to be working. The next, we're doing the objects part. So if the result has objects, result object is not none, right? Then we want to say something like objects image, and then we need to first create some drawing stuff here. So we need to create an image. And for that, we're going to use the original image. That one. And then we're going to create a figure in Python where we're drawing. The way this works is that we will use the figure method. It's available from PLT here, which is matplotlib, right, or pyplot. So from pyplot, we call the figure function. And we need to give it a size. And that needs to be the original image. Width divided by 100. And then the original height divided by 1. Okay, so this works. Now we have a figure. And then we need to set off accesses from Matplotlib. We're very interested in doing a traditional plot, right? And then we want to draw right from image draw dot draw, and that needs the image, and then we have a color, and the one we used previously was cyan, so let's go with that over here as well. Okay, so now we got everything done. So now for each detected object that's in the result object list, what we're going to do is we're going to first print some information about the object. Put stuff here, and then the object name is going to be there, and then again we're going to give it the confidence score, and here we're going to the actual confidence in a floating point with 2 decimals format. That's cool. And then we want to format this string, give it the detected object dot tags, and from tags we're going to have the first, the most probable, and its name. And then similarly from the detected object we're going to tags, there the first object and the config. And multiply that by 100 percentage. Okay, so we're going to print that. Then we need to get the bounding box that is surrounding our object. So that's detected object dot bounding box. And then we want to draw that, right? So maybe let's just do it here. So we're just going to call something a bounding box. And then we're going to make that an object that has, first of all, the left-hand side coordinates, so r.x and r.y. And then it's going to have the outer side coordinates, so r.x plus r dot width, right? Yes. Oops. This is x. Oh, come on. R dot width This is the X part. And then we need the r.y plus height. I don't know why this happens. Okay, so that way we can create a box. So then what we can do is use draw to draw a rectangle, right? And it needs exactly this data structure as a parameter. So we're just going to give it to it. That's going to be the bounding box. Then we have outline equal so select equals color, and then we go with equals 3. Okay, so that will draw the rectangle. And then we need to make sure that we give some text here as well. Let's say annotate. And the text that we want to annotate is the detected object, the tags, and the first one, and its name. And the place where we're going to put that annotation is going to be starting from r.x and y. And that's cool. Then what else do we need? Background color. Oops. Here. We need a color which equals our color. This should be okay. All right, so we're done. So then, once we've done all of that, we want to save that image. So with matplotlib, we need to first call im-show to make sure that we get everything rendered. Come on, we have our image here. Yeah. And then another thing that we want to do is set up tight layout. So we want no padding. And then let's say that we have an output file that will equal objects JPEG like previously. And then we're going to save the figure into that output file. Right? And now everything should be working, so we can print out results, save, and then all right. Let's see if this works. Problem there with I can't spell. So this is on line 94 here. When we do a draw rectangle. bounding box. It's supposed to be a comma. Right. Again. All right, so I found some objects and then it saved them into objects. So JPEG, and this is what we're seeing. So we have a person, a car, a taxi, and a dog here in the image. So that worked well. Our next job is to use the people as well. So let's just go back code here. And we need kind of similar piece of code for people than we used for objects here. So let's see what we can do. So this was okay. And now we can go back to if result people is not none, right? So we have people in there and we want to print something. Yeah, people, image. And then again, we want to do the same thing that we did previously, right? So open the image. We want to do axis off, create a draw, and I want to set up a color. So I'm just going to copy from here. Like that. And now our for is going to be a bit different. So for detected people in result.people.list, right? For each of those, again, we want to create a bounding box. So I'm going to copy paste this. And now it's not detect the object dot bounding box, but it's the people instead. But the bounding box itself is going to be the same. And then the draw rectangle is going to be the same as well. All right, so that way we get a bounding box across the people, and then we can again do the saving of the image part. So I-am-show, tight layout. Just get it from here. Put it here. And now, of course, we need to change the name of the image file. So people instead. And then we're right. And now let's test this. So now we also got the people.jpg here. And it shows us this kind of weird idea of there being, there's the taxi driver there. And there are people on the on the advertisement on top. And there are all kinds of people, right? So it works. And now that we're finished, let's also use this on the rest of the images. So we have images. What was it again? Building, right? So that gives us some information about the capital. Like this should be the same as in the previous, right? So we have large white building with dome and stuff. And then when you look at it, it's the actual capital, right? These are the objects. There's just one object, the building. And then here are the people that were identified. And then the last one would be the person.jpg. So this is actually a picture of the CEO of Microsoft. So we got the person right there. And if we look at the people, I can see that it somehow actually managed to find two persons. All right, but this is the Python part. So I hope you enjoyed it. And instead of the instructions, please use the latest version of the SDK that seems to be working with the current instruction. So thanks a lot for listening, and see you in the next lab. Till then.